Okay. Good morning, students. Today we are discussing ladder friction. See, you know the purpose of ladder. Ladder is used to climb the wall or climb the tree. Sometimes you are trees to cut any fruits, the higher height, no? Okay. So various purpose we are using ladder. Generally, ladder is resting horizontal floor and vertical surface, that vertical wall. So in this diagram, I have drawn the diagram ladder, the blue color, length AB length. Then it is resting rough horizontal surface at the floor, rough vertical wall. See, generally we are resting the ladder. Just understand. So the friction must be available. Then only we can climb the ladder. We can climbing. We can walk. We can go step by step. Otherwise, it is fall down. Yes. Therefore, the friction is available at wall and floor. Just imagine if you are standing, if you are walking on the, if you are standing on the ladder. So the ladder may slip left side at A and downside at B. Yes, because with vertical wall, no. See, it can fall down maybe vertical downward. At A, it goes to left side. So the friction is acting. I told you, no. Generally, friction is acting opposite to motion of the body. Understand? Friction is acting opposite motion of the body. See here, next diagram. So at A, I introduced FF. What is FF? Friction at the floor is acting right side. Why it's right side? The baby ladder goes to the left side at A. Okay. Then I introduced RF. What is RF? Reaction at the floor. You say touching, no. The ladder is touching on the ground, no. Already Newton Thela. What Newton Thela said? Every action, there is equal opposite reaction. Therefore, the reaction is perpendicular vertical upward. RF. Reaction at the floor. Now see the B point at B. So vertical wall, no? So if you are standing, the weight is acting downward. Therefore, the vertical ladder is may going to slip downward. Therefore, friction is upward. FW, friction at wall. Yes. Then the B is touching, no, the bed on the wall, right side. Therefore, every action equals to opposite reaction. Therefore, reaction left side. Students, left reaction left side. Why reaction left side? Because it's touching. Ladder is touching on wall. Okay. Therefore, RW. RW means reaction at wall. Okay. Generally, the ladder having big weight, no? Big weight. We know weight is acting middle of the body. Students, middle of the ladder. So the AB is length. So what is the middle length? L by 2. That's why I introduced the weight is acting perpendicular downward at the middle of the ladder length. Middle of the ladder length L by 2, L by 2. Okay. So in the ladder is inclined position, no? So inclined may be with respect to horizontal, with respect to vertical. So I am taking the ladder with respect to horizontal, alpha. Okay. Now see here. At A, FF. We know generally I told you know friction. Whenever you think friction, F equal to mu into R. Students, F equal to mu into R. Therefore, FF equal to mu F into RF. FW equal to mu W into RW. Yes. Then weight is acting downward. Where it is acting? Middle of the ladder, L by 2, L by 2 distance. So you take theta or alpha. See, in the inclined position, we can take theta or alpha. Then you have to calculate the distance AC. Students, you have to calculate distance AC and the distance CB. See the AB length L. Students, AB length L. We have theta horizontal. Therefore, what is the horizontal distance? L cos theta. Okay. Then what is the vertical distance? L sin theta. Okay. You like Pythagoras theorem, no? Like, therefore, AC equal to L cos theta, BC equal to L sin theta. Okay. Then, see, in the W is acting vertical downward, no? So, therefore, I need horizontal distance with respect to A point. With respect to A point, I want horizontal distance. Okay. So we have distance L by 2. Students, up to A2, the weight is the inclined length L by 2. We have theta. What is the horizontal distance? L by 2 cos theta. Okay. Now, see here. I added additional W1. Students, I added additional W1. What is W1? A man or woman standing on ladder. Students, W is self weight of the ladder. W equals self weight of the ladder. Now, our man, no, maybe me or you, maybe you are climbing ladder, no. Suppose you are standing on the top of the ladder. So your weight is acting vertical downward. So the distance from bottom, you are standing, suppose your unknown distance. Example, you are standing on the ladder, unknown distance from bottom. The unknown distance, D. Students, D or X. Okay, D or X. So what is horizontal distance? You have theta, we know D, no, D cos theta. See here, D cos theta. See, this is called a free body diagram. Students, this is called a free body diagram of ladder. Ladder is touching at two places, floor and wall. It's touching, no, that's for reaction. I introduced RF. See here, RF. Vertical upward. Why vertical upward? Because ladder touching bottom. RF vertical upward. RW. Why right side? Because ladder touching and wall, no, that for RW. Or then YF, what is FF? Why goes to right side? Because ladder maybe fell down the left side. Maybe go to slip to left side. So friction is always acting opposite direction. Students, friction is acting opposite. See, you understand the concept first. Don't memorize. Why the friction right side? Because the ladder may go maybe slip to left side. That's why the friction right side. Similarly, the FW. What is FW? Friction at wall. Why it goes upwards? Ladder maybe it falls downwards due to weight. So the friction is upward. Okay. Then we want all the distances. L cos theta, L sin theta, and horizontal distance. Student, we need horizontal distance. The weight is acting vertical down, no? So from A, what is horizontal distance? How do you calculate? We have theta, that is L by 2. That for L by 2 cos theta. That weight is acting. Okay. Similarly, the D, we have D, we have theta. It's D cos theta. Okay. So remember, this is the you have to remember this one. Okay. So the equilibrium equations. Why we are using three equations? See the block sums we have used today. Summation of H equal to 0, summation of V equal to 0. Because concurrent forces, that is coplanar concurrent forces. Yes. Here see the diagram. Forces acting at different points. See here. Forces acting at different points. At A, the FF acting and RF acting. At B, RW reaction at wall acting. FW friction at wall acting. And the middle of the ladder, W is vertical downward. And the W1, the man weight standing on the ladder. So it is acting at different points. So as per engineering mechanics, if the load is acting at different points, we can say non-concurrent forces. Students, non-concurrent forces. So what is equilibrium equation for non-concurrent forces? F H equal to 0, V equal to 0, moment equal to 0. Students, we study no that beam problem, support reaction problem. No, we apply these equations. Support reaction, same here. Okay. So you have to use summation H0, summation V0, summation M0. Okay. Madhuban, can you read the question? First question, Madhuban.
Yes, sir.
Hmm.
A uniform ladder of length 3.25 meter and weighting 250 Newton is placed against a smooth vertical wall with its lower end 1.25 meter from the wall. The coefficient of friction between the ladder and floor is 0.3. What is the frictional force acting on the ladder at the point of contact between the ladder and the floor.
Okay. Luis, can you read the problem? Luis? Nitish, can you read the problem? Nitish.
A uniform ladder of length 3.25 meter and weight 250 Newton is placed against a smooth vertical wall with its lower end 1.25 meter from the wall. The coefficient of friction between the ladder and the floor is 0.3. What is the friction force acting on the ladder at the point of contact between the ladder and the floor?
Okay. And also they ask a question, show that the ladder will remain
Show
in
that the ladder
equilibrium.
will remain in equilibrium in this position.
Okay. See, in this question, they given only statement. Students, in engineering mechanics, if statement given, you have to draw the diagram. Okay, you have to draw the diagram. That's why we have to read the questions twice or thrice. First, understand the question. So the first word given, a ladder length 3.25 meter. Okay. So you take L, given data, L 3.25 meter. Okay. Then weight. Weight is 250 Newton. Okay. Then distance between lower end and ladder and wall. The horizontal distance. The ladder resting no horizontally from wall to what is a very distance? Horizontal distance 1.25 meter. Then coefficient of friction between ladder and the floor is coefficient of friction between ladder and the floor is 0.3. Okay. Then they asked, see I highlighted the question I highlighted. See here, a smooth vertical wall. Students, when smooth surface there is no friction. Understand? Whenever there is surface there is no friction. Okay. So here they asked, what is the frictional force acting on the ladder and the point of contact floor? That is FF. Okay. They asked, what is the frictional force acting on the ladder, point of contact between ladder and the floor? That is FF they asked. And also we have to verify whether the ladder is remain stable or not. Okay. Now see the diagram, you will understand. See the diagram, the statement. So I draw the colorful diagram. How draw colorful diagram? Just to see the here. The weight is acting. Students, weight is acting at the middle of the ladder. What is the middle of the ladder? The total length how much given? 3.25. So 3.25 divided by 2, 1.625 meter. So weight 250 Newton acting downward. The horizontal distance given. So what is horizontal distance? A to C, 1.25 meter. The question itself they mention the ladder to wall horizontal distance 1.25 meter. The other thing we know at the floor, no, at the floor the friction FF acting right side, RF upward. At the wall, no, FW upward, RW left side. RW means what? Reaction at wall. Students, RW reaction to wall, FW friction at wall. Okay. So in the question they mention the smooth wall. Students, smooth wall. That means friction only 0. Students, whenever they mention any floor or wall, you take the corresponding only. Here smooth wall FW 0. So I removed. See the previous day the FW introduced. Now the FW removed because FW 0. Okay. I told in for ladder you have to calculate all the other distances. For solving the problem, you have to calculate all other distances. Why? It is a non-concurrent force. Why non-concurrent force? Is acting at a different point. Why do we need a distance? Because we are using the moment equation. Students, we are using moment equations. What is the moment? Force into distance. Okay. For moment, we have to choose reference points also. So that purpose, we have to calculate all the vertical distance and horizontal distance. Okay. So here the horizontal distance, they given the question, AC 1.25 meter. So we want BC, CB distance. So this is a Pythagoras theorem, no? We know the Pythagoras theorem, right angle triangle. That is hypotenuse side AB squared equal to adjacent side AC squared plus vertical side. Okay. CB square. So I want CB. So I have taken out the left side, other things right side. Okay, therefore CB square equal to AB square minus AC square. So AB square 3.25 square, AC square 1.25 square. Then take square root. The CB equal to 3 meter. See here, 3 meter. Okay. And also, I told you, we have to calculate the horizontal distance. What horizontal distance? From A to where the W is crossing, the horizontal distance. So that purpose we need angle, no? So okay. So the weight is vertical downward, okay? But we need horizontal distance with respect to A or with respect to C. We want horizontal distance. So how do you calculate horizontal distance? We have only distance 1.625 meter. We have 1.62 meter. What is the theta? Therefore I applied here. See, I introduced tan alpha equal to opposite divided by just 3 divided by 3 divided by 1.25. So alpha equal to 3 divided by 1.25. Students 1.25. Therefore alpha 67.38. Now alpha calculated. Student, now alpha calculated. So now I want distance x1, x2. That is where the weight is crossing. What is x1? 1.625 into cos 67.38. Yes? I told you, L cos theta like that. L by 2 cos theta. Same thing here. 1.625 cos 67.38. Okay. What is x2? Already we have total distance 1.25. AC 1.25. Therefore, 1.25 minus 0.625, the balance 0.625. Now see, all the distance we calculated. All the distance we calculated. So in the question, the friction wall, smooth wall. That's why the FW we did not consider. We do not consider the FW because smooth wall they mention. Okay. So this force is, what is the force? Coplanar concurrent, non-concurrent force. So for equilibrium equation, summation H equal to 0, summation V equal to 0, summation M 0. So what is the H horizontal forces? What are horizontal forces? See the diagram. FF. FF goes to right side plus RW left side minus. So FF minus RW equal to 0. Therefore FF equal to RW. RW means reaction at wall. Okay. Then I am taking this equation 1. Now second equation, summation of V equal to 0. What is the vertical direction? C vertical direction. RF vertical upward. W vertical downward minus RF minus W equal to 0. RF minus W equal to 0. Therefore RF equal to W. What is W? 250. Weight is given. Equation 2. So our aim is FF, no? So we want RW, no? Then only you can calculate FF. So we are using the moment. Students, remember, I am repeatedly telling, whenever you are taking moment, first you have to choose reference point. Students, you have to choose reference. Remember the way we solved the beam support reaction problem, no? In the second unit, I told you, whenever taking moment, first you have to choose reference point. Okay, then you have to identify which forces giving moment, which forces not giving moment. So in this problem, we want FF. Students, in this problem, we want FF. So here two reference point is there, A or B. So I want FF. That's why I am choosing here. And the B is the reference point. So I'm taking the B is the reference point. So the equation I have rewritten, summation MB equal to 0. Then you have to, which forces are not giving moment? I told you, any force comes to reference point. Students, any force comes to reference point, do not give moment. See, RTB is a reference point here. So for RW is acting. So RW won't give moment. Any other forces now coming to B point? No. Okay. So the RW only not give moment. What is moment? Other forces, clockwise movement, anti-clockwise movement. Students, remember again, clockwise movement, anti-clockwise movement. Clockwise movement, positive. Anti-clockwise movement, negative. See, the B point, with respect B, the one force 250 is vertical downward. See here, vertical downward. So see, just imagine it's perpendicular to B. The horizontal distance x2. Students, horizontal distance x2. Okay, perpendicular, no, just draw the horizontal line, perpendicular. Therefore, 250 into x2, anti-clockwise. See here, 250 into 0.625 from CT distance, because we are taking the B's reference point. So 250 into 0.62 minus anti-clockwise. See the FF acting at A, but you have to project. You have to project up to C. Harshal, no. Now see the with respect to B point, what is the distance? 3 meter. Therefore, FF into 3, anti-clockwise. Yes? Is anti-clockwise rotating, just to rotate anti-clockwise, FF into 3. Now see RF. RF here, but with respect to B is the here, upper, but is horizontal distance 1.2 meters. So perpendicular, no. Therefore, RF into 1.25, clockwise. Students, very careful. It will take a moment. Where the force acting, at what distance for a reference point? At what distance for a reference point? Okay. Therefore, minus Fy minus F into 3 anti-clockwise plus RF into 1.25. Y plus clockwise. Then weight is 250 into with respect to no B point, that is a BC. Okay, that is B is the 0.625 anti-clockwise minus. Then we know minus FF into 3. Okay. Then the way what is RF? RF already we calculated. See here RF equal to how much? RF already calculated. RF 250, no? Therefore 250 into 1.25 minus 250 into 0.65. So take out right side. Therefore minus here plus. So you have to multiply here. Therefore final answer minus 3F minus 156. Therefore minus minus cancel. 156.25 divided by 3. That is 52.8 Newton. F. This is our aim. Friction force at flow. That is our aim. But second question they asked, students, second question they asked, equilibrium of the whether show that equilibrium of the ladder. See, for equilibrium, I told you the maximum friction. Just remember, when it's maximum friction, it's going to start. When the body is going to start, there is a maximum friction, maximum opposite force. That force is called limiting friction. So now I'm introducing F limit equal to mu F into RF. So me F given the question, just go and see the question. The me F given, me F equal to 0.3. RF already calculated, RF equal to 250. What is the maximum friction? 750. Students, the maximum available friction 750, but our involving friction is 52. Definitely body is not going to start because the available friction 75, but our actual condition friction is 52. See here, F limit greater than FF. That is, the amount of the force of friction available at the point of condition 75 is more than the force of required for equilibrium. Therefore, the ladder will remain equilibrium. Here you have confusion. What doubt you have? How to take a moment? So why I'm taking a moment with this V point? Because we want FF. See here, reference point only you can A or B, you can choose A or B. Here I'm choosing B point. Why? Because I'm taking a moment with respect to B, and also I want to value the FF value. Therefore, with respect to B, always see the horizontal. See see 250 here. But what is the horizontal distance? 0.625, no, perpendicular, no. So W into 0.625, anti-clockwise. That is 250 into 0.625. Now RF. RF is the here, but with respect to horizontal, no, B with respect to horizontal is perpendicular. Therefore, RF into 1.25. Clockwise, no, plus. Now see the FF acting at A, but you can project where is going, this line of action. See the FF line of action goes to C point. So C point is a vertical with respect to B is a vertical, no, what is the distance? 3 meter, perpendicular. Therefore, FF into 3 clockwise. Yes? Therefore, we calculated. Very important questions. This see here, here one of the important word is given, smooth vertical wall is mentioned. That's, we did not consider that FW0. Okay. Very simple question. Next, I am moving to next question. Here also, Luis, can you read the problem, Luis?
Yes, sir.
Hmm.
Ladder 5 meter long rests on a horizontal ground and leans against a smooth vertical wall at an angle 70 degrees with the horizontal. The weight of the ladder is 900 Newton and act at its middle. The ladder is at the point of the sliding. When a man weighing 750 Newton standing on a rug 1.5 meters from the bottom of the ladder. Calculate the coefficient of friction between the ladder and the floor.
So here one man is standing. In the previous schooling, the man is not standing. Students, here a man is standing. At what distance? 1.5 meter from ladder. What is the man weight? 750 Newton. Man weight 750 Newton. Ladder weight 900 Newton. The angle horizontal 70 degree. L 5 meter. Smooth vertical wall. Students, smooth vertical wall. So friction at wall 0. See, they did not mention anything. Smooth, that's we have to understand. So smooth means there is no friction. They asked, calculate the coefficient of friction between ladder and the floor. Now see the diagram. See ladder length 5 meter. One man weight, man standing 1.5 meter from bottom. The man weight W1. The weight of the ladder acting middle L by 2 distance. That is 2.5 meter, 2.5 meter. Angle 70 degree. It's not a free body diagram. It's a space diagram. Now see the free body diagram. So you have to calculate one man is standing at what distance? 1.5 meter. Therefore, what is horizontal distance? The d cos theta. You see the next diagram. See, I removed FW. Why I removed FW? Because smooth wall. So only reaction is here. Okay. So now you see the angle 70 degree, length 5 meter. What is horizontal distance? 5 cos 70. Students, 5 cos 70. What is vertical distance? 5 sin 70. A man standing at what height? 1.5 meter. That horizontal distance? 1.5 cos 70. Where is the weight is acting? Students, 2.5 meter, no. This is a concept. They did not mention anything, but we have to take weight is acting middle of the ladder. That is 2.5. What is horizontal distance? 2.5 cos 70. Why FF acting in the right side? Because ladder may goes to left side. Why RF is upward? Because touching horizontal. Therefore vertical upward reaction. So you get smooth wall. At B smooth wall. Therefore FW is touching on the right side. Therefore reaction left side RW. As usual, see here, summation H0, summation V0, M0. What are horizontal forces? FF minus RW. FF minus R. Okay, equation 1. What is the vertical forces? See vertical forces. RF minus W1 plus W. Okay. Here, RF minus W1, W minus W1. That is a man's weight 750. No? Yes. The given question, no? Man's weight 750, ladder weight 900. They are acting downward. Therefore, RF equal to 1650. That generally we know what is FF. See, whenever friction is just remember F equal to mu R. Always remember. Therefore, FF equal to mu F into RF. So we RF calculator 1650 mu F. Okay. Therefore, FF equal to 1650 mu F. Now taking moments, third equation. Here also, I'm taking moment with respect B point. Okay. So we calculate all the distance. See here, all the distances. We calculated all the distances. What is the horizontal distance? 5. That is L cos theta. What is L? 5 meter. Therefore, what is the 5? 5 cos 70. Horizontal 1.7 meter. Vertical distance? L sin theta. What is L? 5. Theta 70. Therefore, 5 sin theta. Okay. And the man standing 1.5 meter. What is the horizontal distance? 1.5 cos 70. Weight is acting 2.5 meter. Okay, then what is horizontal distance? 2.5 cos 70. What is the balance distance? Students balance distance 1.751 minus 0.855. Okay, therefore, taking moment, students taking moment with respect B, just remember. So here, so what is the first? W into 0.875. Anti-clockwise, students, W, ladder weight. Okay, then W1, man's weight, into 1.197. Students, 1.197. See the RW not giving moment. Students, RW not, why RW not giving moment is a reference point. Okay. The other forces W into 0.855. W1 into 1.197. Then FF. See FF acting here, just to project at C. FF into 4.7 meter. Anti-clockwise minus. Just remember, see, while taking moment, you choose the reference point, first step. Then identify which forces are not giving. Any force comes to or goes from reference point. not giving moment. Then clockwise or anti-clockwise with respect to reference point and distance also. So f of acting here just to project C. Therefore f of into 4.7, that is vertical distance. Same RF. RF into what is horizontal distance? 1.71 clockwise. See here. Minus f of into 4. Why minus? Anti-clockwise. Minus W1 1 and 1.97 anti-clockwise. Minus W 0.855 anti-clockwise. RF clockwise no with respect to B point 1.71. So already we have f of equal to 1650 mu f. Therefore RF also already calculated. RF already calculated 1650. Just see how to apply here. See how to apply here. So W1 given W1 750, W 900. Okay. So everything applied here. The final equation that is minus 4.7 f of equal to minus 1154.25. Therefore, what is f of 245.585? That is our aim. They asked mu. We know f of equal to mu f RF. F of equal to mu f into RF. Okay. Therefore, what is f of already f of equal to 1650 mu f. Okay, we calculated f value. Therefore, mu f equal to that is f of divided by RF. Mu equal to 0.15. Very simple. See this students, you remember whenever you solving the problem on the starting itself, we can expect in the monthly test questions. Suppose if a ladder, I'm a third unit. Say what topic, sir? What is important question, sir? Which topic you are studying? The first two questions, no, that is important questions. So if a ladder, the first two questions important. And the horizontal block, no, the horizontal block, first two problem, three problem we discussed. You take first two problem important, like that. But the first 2 units I have selected questions, so you can expect in the coming next unit test you can take us this one. Okay. So with that I want. So here this question, any doubt, students? So here the previous, what is the difference between previous question this question? The previous question they mentioned weight of the ladder only, not man standing. In this question, the man is standing at what distance? 1.5 meter from bottom. Okay. They asked calculate the coefficient of friction between ladder and the floor, mu of. Okay. So we draw the free body diagram. And FW we take a 0. Why FW 0? Smooth vertical wall. Okay. Then we calculate all the distances. Students, all the distance is your mathematical knowledge. We know angle 70 degree. We know length AB 5 meter. What is the horizontal distance? It adjacent side we know no 5 cos theta. That is L cos theta. The opposite side L sin theta, like that. 5 into sin 70. 5 into cos 70. Under W1 that is a man standing at what height? 1.5 meter. What is the angle? 70 degree. What is the horizontal distance? 1.5 cos 70. Similarly, the W, generally ladder weight, see ladder weight acting middle of the ladder. Middle of the ladder, what is the middle here? 5 meter. What is the middle? 2.5 meter. Therefore, 2.5 into cos 70 horizontal distance. And also you calculate the balance distance. Say horizontal distance 1.771. Here the weight is 0.855. What is the balance distance? With respect to C, what is the balance distance? Similarly, with respect to C, what is the horizontal distance? W1. That's why we calculate here. See here, we are calculated. 1.71 minus 0.513. That is the man right. Okay. Why we are calculated? Because we are taking moment with respect B point. Okay. So you have to choose here reference point A or B. Yeah, I'm choosing EB point because we want in this question we want FF or mu of. That's why I am choosing A is B point reference point. And identify which force is not giving moment. Any force comes to reference point. Remember, students, remember, any force comes to reference point does not give moment. And the moment there is a two moments, clockwise moment and anti-clockwise moment. What is moment? Force into perpendicular distance. Okay, you have to rotate yourself with respect to reference, rotate horizontally distance, then rotate clockwise, anti-clockwise. Clockwise means positive value, anti-clockwise means negative value. Okay, let's say. So with that, I want to stop today class. I want conclude. Therefore, any questions? Any question?